When it comes to energy, plants are a lot smarter than humans. Evolution helped plants develop perhaps the most efficient power supply in the world: photosynthesis. While humans are unable to perform photosynthesis naturally, scientists created artificial photosynthesis or AP systems to produce liquid fuels and reduce CO2 levels in the air. For an AP system to work, it has to be able to do two crucial things. First, and this one may be obvious, the system should be able to efficiently absorb sunlight. Second, it should be able to split water molecules into oxygen and hydrogen. While the oxygen is released into the atmosphere, the hydrogen can be used as a source of clean energy. So, how exactly are scientists trying to replicate this natural process, and how successful have they been so far? Through photosynthesis, plants use sunlight, CO2, and water to produce glucose, which becomes fuel for the plant. Researchers mimicked this natural process by using the same green light portion of the visible light spectrum to convert CO2 and water into liquid fuel. To speed up this process, researchers used electron-rich gold nanoparticles. Gold nanoparticles are efficient at absorbing the sunlight and do not break down or degrade like other metals do. At the moment, the basic steps in artificial photosynthesis work, but this process is nowhere near as efficient as it is in plants. Plants convert 1,100 billion tons or 1,000 billion metric tons of CO2 into organic matter every year. And that's using only 3% of the sunlight that reaches Earth. If scientists succeed in creating an efficient AP system, it could potentially suck the excess CO2 out of the atmosphere and put it to good use. AP can produce liquid fuels without generating any harmful byproducts. Liquid fuels are ideal because they are easier, safer, and more economical to transport than gas. And since all the ingredients required for AP are plentiful in nature, it could be an endless, relatively inexpensive supply of energy, and to make things even better, it could be stored for later use. This means we could fall back on such fuels when other clean energy systems like solar or hydroelectric systems aren't producing adequate energy levels. Also, the process can be tweaked to produce more than just one type of fuel. Methanol is another possible output of artificial photosynthesis systems. But we're not quite there just yet. It took plants billions of years to develop photosynthesis, and replicating what happens naturally in green plants is not an easy task. Researchers have been able to make hydrogen and water from sunlight on a small scale in labs, but for these processes to be of use, they must be practical on a large scale. As of right now, we do not have a system robust enough that it can be deployed on a commercial scale. Another major disadvantage of artificial photosynthesis is the cost. Catalysts such as platinum and gold are required to split water with the aid of sunlight, but these metals are not cheap, which makes the whole process quite expensive. Still, as technology advances, there is hope that these artificial photosynthesis systems can be a part of the solutions to our energy needs as well as to the dangerous rising CO2 levels we face.